Question 5 is coming from parametric differentiation. The parametric equations of a curve are these ones here. Show that dy dx is equal to that. So we need to get dx dt. This one here, remember, when you differentiate, this is an exponential function. So when you differentiate an exponential function, e to the power of f of x, we just get this f of x, we differentiate it, and then after we multiply all through by that exponential. Okay, so we need to apply this one here. And also, since this one is a product of two functions, then we are going to use the product rule. So I'll keep t constant, then I differentiate this e to the power of 2t with respect to x, then now plus e to the power of 2t, and then differentiate the t with respect to t. Here we are using product rule. Okay, then this one is going to give us t, then times, of course, when you differentiate here, applying this one here, we shall get a 2, then e to the power of 2t, then plus e power 2t times 1, of course. Now, what is common here? E power 2t is common. So here we have 2t, and then here we have a 1. So plus 1. Then we shall go to y. If y is equal to t squared plus t plus 3, that means that dy dt is going to be equal to 2t plus 1. Now, this simply implies that dy dx is going to be equal to dy dt times dt dx. Okay, here we are using chain rule. Now, dy dt is 2t, then plus 1, times dt dx. dt dx is 1 over dx dt. So we shall have 1 over e to the power of 2t into 2t plus 1. You can see that this one can easily cancel with that. Then we remain with 1 over e to the power of 2t. And of course, this means that dy dx is going to be equal to e to the power of negative 2t as required. Part B, hence show that the normal to the curve where t is equal to negative 1 passes through that point. Now, if I have a curve and then this line here, which intersects the curve at one point, is what we call the tangent. Okay, this is the curve. Then that line which is perpendicular to the tangent is what we call the normal. Okay, the normal. Now here what we need to do is to find the equation of the normal, and then we see that when x is 0, is this the y coordinate? That is all. Now, to find the equation of a straight line, you know that we need to get the gradient, okay? So for t, which is equal to negative 1, what is dy dx? dy dx here is going to be e power, remember it is negative 2t, so this one will be e squared. Now, this is the gradient of the tangent. Remember, at the point of intersection, the curve and the tangent have the same gradient. Okay. Now that therefore implies that the gradient of the normal, remember for perpendicular lines, m1, m2 is equal to negative 1. So gradient of the normal is going to be equal to negative 1 over gradient of the tangent. You see? So that is that. Now, again for t, which is equal to negative 1. Remember, to find the equation of a straight line, you need to get its gradient. So we have the gradient, and also one point through which, at least one point through which the line passes. So if t is equal to negative 1, what is x and what is the y? So we need to get that coordinate. And when we go back here, x is given as t e power. We are having these ones here. So we are supposed to substitute here to get that coordinate. Okay, I mean that point. So t x is going to be, remember it is t e power 2t. So we are going to have negative 1, then times e power 2 here times a negative 1. So that is a negative e to the power of negative 2. Okay, and then the y coordinate is t squared, then plus t plus 3 plus t plus 3. So we shall put here negative 1, we square it, that is a positive 1, then minus t, that one disappears, then plus 3, and then this one will give us a 3, meaning the point we have is negative e power negative 2, then 3. Okay, so equation of the normal is going to be, remember we can use y minus y1, which is equal to m into x minus x1. So this will be y minus y1 is 3, and then the m, we got it here, negative 1 over e power 2, then into x minus, and then x1 is this one here. And that one, I can even write it. So if it's minus minus, that will be a plus. Okay. E power negative 2. Now, here, x coordinate is 0. This is the equation of the normal. Okay. You can simplify it. So when x is 0, do we get this y coordinate? Okay. Because a coordinate, I mean a point, lies on a straight line if it can satisfy its equation. Okay, so we can say for x is equal to 0, what do we get? So y here, I can actually take this 3 this side. Now here we shall have negative 1 over e squared, and of course x here is 0, then plus this one is going to be 1 over e squared, then plus the 3. So of course this one has gone, so this and this, when we multiply, that one will give us negative 1 over e power 4. The denominator multiplies with the denominator, okay? And then plus 3. Actually, what you're seeing here is exactly what is here. If I write the positive first, that will be 3, then minus 1 over e to the power of 4. So since I've gotten this y coordinate by substituting the x coordinate, which is 0, that implies that the normal passes through that point. So I conclude and I say, therefore, the normal passes through the point 0, 3 minus 1 over e power 4. That is that.